Welcome to EDU World Space.
Problem 3.112. In this problem, we have to find an equivalent force coupled system that can replace these four forces by a single force, and its point and the point of intersection of line of action of that equivalent force with the bottom edge of this bracket. Alright, so first of all, we will try to replace these forces that is acting on this pulley by a single equivalent force coupled system at its center in both the pulleys. So first of all, let's say this was the bracket, alright, and this is point A and this was the point B. So, and we have to replace a single equivalent force here. We can observe one thing, that both the forces are in downward direction. So an equivalent force will be in downward direction, and let's say that is RA, and its equivalent and a couple that is acting here will be MA. Let us say that. And similarly, we can replace the forces since both the forces are parallel to each other and making an angle 25 degree. So their resultant will also be in the same direction. So let's say this resultant is RB, which will make an angle 25 degree with horizontal and a moment that will act at point B. So this will be the equivalent system in which we have replaced the forces present in the belts on individual pulleys by an equivalent force coupled system at the center of the corresponding pulley. So we have to calculate these values of RA and RB. So RA can be calculated as, since two forces are acting on the pulley A and both the forces are in downward direction, so considering the downward direction to be positive, so RA will be 120 plus 160 pound, and which is 280 pound. So if we assign it a direction, for that we have to define the coordinate system. Let's say this direction is x-axis and this direction is y-axis. So RA can be written as 120 pound minus j cap. So it can be written as minus j cap. So this is equals to minus 280 j cap. Now talking about the moment that is acting at point A, so we can calculate the moments because of these two forces about the center of the pulley. So the equivalent moment that is acting at point A will be, now considering here the anti-clockwise direction to be positive direction, so this 120 pound force is going to cause a anti-clockwise couple. So this will be a positive couple. So this will give the positive moment value 120 multiplied by the perpendicular distance, that is 2 inches. Now the moment because of this 160 pound force will be in clockwise sense, so this will be minus 160 multiplied by 2, and unit of these moments will be pound, inch, and since this is our xy plane, so these moments will be in j cap in k cap plane. So this will be k cap. So this comes out to be minus 80 pound inch k cap. Now talking about the equivalent force acting at point B, and again considering the downward direction to be positive direction, since here nothing is mentioned, so we can do one thing that we can resolve these forces individually in I cap and j cap component. So these two forces are already acting in parallel to each other and making an angle 25 degree with the horizontal. So if they are parallel forces, then we can directly add up them, and the equivalent force, if we talk about the magnitude of this force, this will be 210 plus 150 pound, which comes out to be 360 pound. So now if we talk about its direction, so we can write the equivalent force at point B will be 360 pound, which will be making an angle 25 degree with horizontal. Now talking about the moment that is acting at point B, that will be, since this 210 pound is going to cause a clockwise couple while this 150 pound is going to cause an anti-clockwise couple, so considering the anti-clockwise couple to be positive couple, this will give minus, first of all, if we write the moment because of 210 pound force, so this will be 210 minus 210 multiplied by perpendicular distance, that is 1.5 inch, and plus 150 multiplied by 1.5. So all these forces will be perpendicular to the plane, that is in k cap direction. So this comes out to be minus 93.6 pound inch k cap. Now we can see here that RB can also be written in form of I cap and J cap as 360 cos 25 I cap plus 360 sin 25 J cap. Now we have to they were asking in first part the equivalent force that is acting on this system. So equivalent force will be RA plus RB, so which comes out to be RA, we have already calculated here, is minus 280 J cap, and RB is plus 360 cos 25 I cap plus 360 sin 25 J cap. Now we can collect the coefficients of I cap and J cap, so this comes out to be 326.27 I cap minus 127.86 J cap. Hence the result of the answer for the first part is that the equivalent force will be 326.27 I cap minus 127.86 J cap. Now we observe one thing, that in this problem the coordinate system is not given. We had assumed this coordinate axis, so our final answer should not be in our assumed directions. So we can write this resultant vector in some another form as resultant vector will be, we can write its magnitude, and its magnitude will be under root of 326.27 whole square plus 127.86 whole square, and which comes out to be 350.43. So we can write its magnitude as 350.43 pound, which is making an angle, since I cap and minus J cap. So this will be in, this is positive I cap, this is minus J cap. So resultant will be in fourth quadrant, which will be making an angle theta, and theta can be written as tan inverse y component, that is 127.86 divided by 326.27, and if we solve this, so it comes out to be 127.86 326.27, it comes out to be 21.4 degree. Alright, so this is the answer for first part. Now in second part they are asking the point of intersection of line of action of the force with the lower bracket. So for that we can again redraw the bracket. So this was the bracket, and in this problem this was point A, this was the axis of the bracket, and let's say this was the point B, and we have to find the point of intersection. Let's say point of intersection at point M, which is at a horizontal distance from point B is at a distance of D. So here if we draw the forces, resultant force that was 326.27 I cap, and our I cap j cap direction, this was x-axis and this was positive y-axis. So if we draw here, so our force were in this direction and in this direction, resultant force components. So this vertical component was 127.86 pound and the horizontal component was 326.27 pound. So and this distance was given in the problem as 1 inch. So we can calculate moment about any point, and here I'm going to consider the point to be about the point B. So if we talk about the moment about point B in equivalent system, this will be this we should assign a direction for the moment and considering the anti-clockwise direction to be positive direction. So this 326 pound force is going to cause an anti-clockwise couple. So this will be plus 326.27 multiplied by 1, while this component will also cause the counterclockwise couple. So this will add up them and this will be 127.86 multiplied by the perpendicular distance is D here. So multiplied by D. And now we can equate this moment about point B from the actual system that was in the diagram given here. So we can see here that if we calculate moment about point B, so this will be, first of all, we can add up these two moments that we have calculated and we can multiply this RA vector since it is vertical, since it is in the vertical direction. So its vertical distance, so its horizontal distance or perpendicular distance from point B is given in the diagram as 6 inches. So directly we can solve it as moment because of this RA will be 6 multiplied by RA, and this RA is going to cause an anti-clockwise couple. So we can write the total moment will be MA plus MB plus RA multiplied by perpendicular distance, that was 6. We have got the value of MA above and that was minus 80, MB was minus 93.6 and RA was minus, since we have already considered its direction, it is going to cause a counterclockwise couple, so we can use its directly valued 280 multiplied by 6. So if we equate this term by this equation, so in both of these only one variable is there, that is D. So we can get the value of D and it will, so D will be minus 80 minus 93.6 plus 280 multiplied by 6 minus 326.27 whole divided by 127.86. If we solve this, so we can get the value of D, which comes out to be 9.23 inches. So it means that the point of intersection on the lower edge of the bracket will be at a distance 3.23 inches along the axis left of the point B. So we can write it here as our final answer to be point of intersection of line of action of resultant force with lower edge of bracket is in left of B at a distance 9.23 inches along axis, and what is the depth? Depth was, this was given 1 inch, so we can also include that. And at depth of 1